On this page we're going to work through the pictorial model and the elevation and end elevation here, depicting the double hyperbola. We're going to be seeing the terminology, where it comes from, and like in the previous videos where I covered parabola and ellipse, we will again be looking at focal spheres, focal points, vertices, directrices, and all other aspects that we have already covered, plus a few more different terms that will come up here at the later stage. To get started here, once again, I'm going to just label the pictorial sketch, and starting off as I did in the previous two videos with the section plane that actually produces the shape. So the section plane that produces the shape goes through both naps, or both halves, of this double cone, producing a hyperbola on each side as it cuts. In this case here, we have two focal spheres. Just like in the other two examples, the focal spheres are in contact with their cone and they're in contact with the section plane. And the same goes for this one down here, focal sphere in contact with its cone and with the section plane that stands up here. The focal spheres have a circle of contact around them where they come in contact with their cone, and that being extended onto plane, I'll call this plane number 1 down below, and when plane 1 is extended out to hit the section plane, it gives us a directrix. Very similar up top, the sphere comes in contact with the cone around this circle of contact, extended onto plane 2. And when plane 2 extends and intersects with the primary section plane, we get a directrix. Each curve, each individual curve, has a vertex which lies on the central axis, which I should have labelled here as well. Central axis up through the object. Each curve has a vertex. And I think one of the final things to label is where the focal sphere touches the section plane, we get a focal point. Often referred to just as a focus. And again, where the focal sphere touches the section plane here, we get a focal point. That's all of the important terms now added here. We're looking this time for the two curves, the hyperbola facing up and the hyperbola facing down, and of course all of the extras that we've talked about here will feature in our 2D drawings. What we have here is an end elevation showing an edge view of the section plane. It stands here represented by that line, the edge view, and when we look in at the elevation, we get the true shape of each section cut. Each section cut, you can straight away mark in the vertex V and the vertex there V. We have an axis going through the object. And now the first thing we're going to do at this side is going to be to find the focal sphere up top and the focal sphere down the bottom. I'm going to draw the center line that goes up through these two, because that's going to give me the center of the focal sphere, bottom and top. The focal sphere has to be in contact. I'll just draw the top one first. Has to be in contact with both generators shown and in contact with the section plane, so it has to touch both sides of this angle. So I'm going to bisect this angle. That should give me the center point of the focal sphere. Once again, getting my normals. Before I draw my circle, I want my 3 normals to get my 3 points of contact. Section plane is vertical. This normal is going to be horizontal. And then the sliding set squares to match tangent angle. Slide down for the normal angle. Take my compass and always just test it first to make sure you're accurate. So does it touch all 3 points? That looks good. Once I do that, I have established, first of all I should mark the, right here is the vertex. Where the section plane exits its cut on the edge of the object is the vertex. Should have leveled that before now, and this guy right here being the vertex as well. But where the focal sphere touches the section plane right there is the focal point. That can then be projected to the elevation and labelled point F. The 2 points of contact between the focal sphere and the edges or edge generators of the cone can be connected to find the full circle of contact that makes. And the circle of contact extended through with a plane, and I have that called plane number 2 in the 3-dimensional view here. And plane 2 defines the exact position of the directrix. I repeat the very same set of steps down below to find the focal sphere, the focal point and the directrix, and bring them over as well. Point here is the focal point. Which can again be projected. Point F. And at the end of the normals, where the cone makes a full circle of contact. The sphere we extend, and that one I had called plane 1. Plane 1 defining the point view of directrix. That is the directrix line appearing as a single point here, and the other directrix line appearing as a single point here. If it's a point view here, we can project it to our next view. Let's call it. Now we get our directrix line here. Take it from there. I think that's all of the key areas labelled in here as well. So look, label on the pictorial and the orthographic. So the section plane is shown, the vertex, both of them shown, the focal sphere, both shown there in green, the focal points given as well in both views, the horizontal cutting planes, so both my plane 1 and plane 2, and the directrix. The 2 directrices shown top and bottom. So that's a lot dropped in there. Taking it from there, that's the 3D. That's how these curves are derived. They're derived from section through the cone. Taking our section through both naps of the cone and showing the true shape of that section being a hyperbola, and using our focal spheres, exact same as the 2 questions that came before this, the parabola and ellipse, using 2 focal spheres, 1 in each nap of the cone, to find focal points, circles of contact, planes, directrix, and so on. Now, the other few terms that are here, very important, really important that you know these. Let's put in the easy ones first off. That point there is the focal point, or focus. That point there is also the focus. Next, at the top of each is the vertex, and the top of this one is the vertex. And again, we're more familiar with seeing these down their side like this. Generally, I, as a teacher, and as most students will be when they're through the topic, will be more familiar with seeing them down their side. They could be presented either way, but this is the real kind of understanding of the 3D methods. There's a lot of 2D to come after this. Next, a term you might be familiar with from maths is an asymptote. So it's just right there. So asymptote. This line here that goes through the center point and nears each end of the curve is called an asymptote. And there's a second one down here. And an asymptote is like the limit of a curve, and the larger that those cones will get, the nearer the curve will get to the asymptote, but it will never reach or never touch the asymptote. So an asymptote is like the limit of a curve, and they say the asymptote will never reach or touch. They will get closer and closer and closer, but will never touch each other. So that's the asymptote, which is there. I have also used the vertex, which is here. The directrix, if I just drop them in here, I'll just label them this time as D1, and I'll just leave directrix and write down D1. And there's D1 for directrix as well. The axis, once again, is at 90 degrees to the directrix running through the center of the object. The transverse axis is represented, I'll just add a colour in for that. The transverse axis is represented here. It is the distance between the 2 vertices. Next up, the conjugate axis lies at 90 degrees to the transverse axis through to center point. That right there is the conjugate axis. And I think the final piece of terminology to put in is the auxiliary circle. Auxiliary circle. And just a point of note before we leave this page, point of note there is that the asymptote lines cross through the auxiliary circle at points touching the directrix right here. All three intersect. So the directrix line, the asymptote and the auxiliary circle have a point in common. They have actually 4 points in common. So if you were ever doing a question where you're given the auxiliary circle and you are given the asymptotes, then you would have the position of the directrix, or vice versa. You had the transverse axis, this orange line, you'd be able to draw the auxiliary circle, find the directrix, get your asymptote points. That might all come up as part of a question. That's the terminology to do with the hyperbola. Now there's a lot here, there's an awful lot going on there. You will have to be familiar with the terminology, you will have to know what they are, and when it does come to the time, there's a lot more understanding and meaning to this, and there's a lot more drawing to do here, utilizing our knowledge of this as well, coming up in the coming classes. But for now, get yourself familiar with those terms, recreate that sheet in your own time, and just fill in the keywords as well here at the bottom. Thanks for tuning into it, folks.